Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast.
Hello, everyone. Welcome to the Everything Building Envelope podcast. This is Paul Beer, CEO and Managing Member for GCI Consultants, and I will be your host today. I thought it would be interesting to talk with our very own senior consultant, Dan Johnson, about his experience in the world of windows. Dan joined our team of experts in April this year and is a strong addition to our team. So, Dan, welcome.
Yeah, thank you, Paul.
So, Dan, why don't you tell our listeners a little bit about yourself, and then we'll go back and do a deeper dive.
Okay, thank you, Paul. Yeah, and I'll be glad. As I mentioned, thanks for allowing me to join GCI. And kind of my experience is my college education is I was engineering technology with a quality management emphasis. And then when I graduated with college, of course, the typical, you need the experience. So I got a job as a test technician with Twin City Testing Corporation. My role there, I was their laboratory air, water, structural, and acoustical technician. We tested anything from doors, windows to interior walls, exterior walls. And then also I was responsible for doing the field testing for windows and doors and curtain walls for air infiltration and water penetration testing, and also the acoustical testing in the field. I was there for a couple of years, and then when architectural testing wanted to expand into the Midwest of the United States, they contacted me to assist. And there we built a lab. That was in 1990. In that lab, we did the full series of testing for air, water, structural for window and door manufacturers. We also tested on insulated glass and also safety glazing. We were a small lab at the time. We had, I'll be honest, we had 3 employees, but as we grew, my responsibilities also grew along with that. So I was responsible for initially, for basically all of the field testing, which ranged from, quality control testing to all the way through forensic evaluations. And then as we grew, we outgrew the space and we moved into a larger space, which allowed us to expand into the thermal testing realm, which thermal testing is basically, determining your U values and your condensation resistance factors based on the NFRC and AMA test procedures. And so I assisted our company, and we built the thermal chamber at that time it was St. Paul, Minnesota, and then also did the installs, the evaluations, became the person in responsible charge for NFRC. And then also, along with thermal testing, we expanded into more of the insulated glass testing, so we tested mostly for the Insulated Glass Certification Council, and then also for ALI and NAM for their certification programs. We lasted there for about 15 years. During that time, we were purchased by Intertech Testing Services, and then we ran out of space once again, and then we moved into a new building. So then during that time, I assisted in design and did the full move to a new building. And one of the biggest reasons for the move there was we were able to, we had over 30 feet of interior wall, our ceiling heights. We expanded into the full service mock-up testing also. And so during that time, I was the person responsible charge for thermal testing, the air, water, structural testing, the mock-up testing, the insulated glass testing, and then also I grew into managing more of the field testing. Prior to then, I don't have an exact count, but it's definitely thousands of field testing tests that I perform personally. And then I'm also a administration master professional certified individual, so which allows me to do a full review of both residential and field quality control testing, and then also to continue divulging into the AMA 511, which is the forensic evaluation. And then one thing that I forgot to mention is during this whole time, I was also a few window manufacturers. So I was their expert when it came into litigation, potential litigation and those types of cases. That's kind of a background on my work history, which goes kind of hand in hand with the actual hands-on. I was and still am a representative with various trade organizations. I'm currently on the Fenestration and Glazing Industry Alliance. I'm the co-chair of the Method of Test Committee, which what that involves is we review all the different test procedures, primarily the field test procedures, but pretty much all the test procedures, just continually review them and change them as they need to be revised and they need to be changed. And I'm also a member of the E6 committee with ASME International, which the E6 committee deals primarily with the exterior building components of the building, which goes along with with my FGI associations. So that's kind of a recap of my history. I don't know if there's anything you'd like to talk a little bit more in depth with, Paul.
Well, there's a lot. Wow, that's impressive. I know that you did have a experience with the lab field and whatnot, and then the litigation work as well. Let's try to break this down a little bit, and let's just talk about some of the things that go on in the laboratory. You mentioned several times air, water, structural. So can you just talk a little bit more about why do they do that, number one, and then number two, what's involved with that?
Yes, most definitely. I apologize for kind of breezing over that a little bit. When I mentioned air, water, structural, that's just kind of a synonym for the certification testing that is done by window manufacturers. And the reason that you want to have quality control testing done and certification testing done by window manufacturers, window and door manufacturers for their products is, every window manufacturer has a full team of engineers, and they're continually designing and making new and improved window products. In order to confirm and verify that those window products are to industry standards, which the industry standards right now is NAFS, which is National American Fenestration Standard, which is kind of, when I mentioned air, water, structural, that is kind of, it's more than just air, water, structure, air infiltration, water penetration, and structural performance. So those are the three main components that gets tested to in order to determine the performance levels, performance grades of different window and door products. So the way it's set up is a window manufacturer will have a new design they want to bring into market. They will typically have a bunch of their R&D testing done already to kind of get most of the bugs worked out. But then they'll send it to a certified and accredited lab, which is one that I manage and work for. And the lab would test it to the industry standard, to that NAFS standard. And then you would test it for air infiltration, which is typically done at 1.57 PSF, which is equivalent to a 25 mile per hour wind. And then also, if it's a higher level architectural grade window, then you test it at 6.24 PSF, which is a 50 mile per hour wind. You tested both infiltration, which is the air being drawn into the building, and then also exfiltration, which is the air being exhausted from the building. And then you measure the amount of airflow that occurs at simulated wind speed, and that gets converted into cubic feet of air per minute per square foot of window opening. And there is based on the different performance levels, there's a certain amount of air that can leak through the opening in order to pass the test. Once you have passing tests for the air infiltration, then you move on to the water penetration testing, which what that entails is you draw a static load from the outside of the window in to simulate different wind speeds and test pressures. During that time, there is a water spray that is put on the exterior of the opening also, that it's approximately 8 inches an hour of rainfall. It's a real heavy mist is basically what it is. And then you run the test for a residential grade or a light commercial grade. You run the test for 4 5-minute cycles, which what a cycle is you have 5 minutes with water spray plus pressure. Then you have 1 minute where you reduce pressure to 0 to simulate to let the window relieve itself, and then 5 pressure, 1 off, 5 pressure, 1 off, and then 5 pressure, and then you complete with the 1 off. And during that time, you can't have any water overflow the interface of the window opening or through any frame corners. And this is done at various test pressures to determine what performance grade. Of course, the higher the test pressure, the higher the performance grade. And then once the water penetration testing is done, then you go into uniform load structural testing, which basically what that is you increase the amount of pressure to simulate the wind speed that the window is going to be rated at. So like if you have a design pressure of 35 PSF, which would be a PG 35 in the industry, you test it for a 35 PSF. You measure the deflections on the key components for most grade windows, the residential, light commercial grade windows. It's just for information only. But then when you get to the architectural grade window, then your window can't deflect more than the length of that member divided by 175 in order to get a passing result. Then once you have your 35 done, then you go to 1.5 times that, which is called the structural overload. And that structural load testing is done more or less as a safety factor. It's the window designed for that 35 PSF performance grade because it passes both the air, water, and the low deflections. But then you want to make sure that just as a safety factor, you go to 1.5 times that. So for example, if we're using a 35 PSF, for example, 1.5, so you tested for a positive 52.5 PSF load on the window for 10 seconds. And during that time, you can't have any excessive permanent deformation, or you can't have any components that break. And then at the completion of that, then you'll do the negative, which negative 52.5 PSF, which is you're trying to blow the window out of the opening. And then the same criteria. You can't have any excessive permanent deformation, and you can't have any breakage. So once you pass those 3 key components of the NAF standard, if the manufacturer is happy with the performance grade that it received, well, then you move on. If they want to go higher, then you inching your way higher at 5 PSF increments. But it has to pass both the water penetration at that higher level plus the structural performance at that higher level. Once you get to the level that the manufacturer would like to rate their product at, then you move on to the forced entry resistance test. What you're trying to do is you're trying to manipulate the locks with a few different components and tools. And then you also put force on the locks just to make sure that they're structurally sound. So if someone wants to break in, the homeowner can feel confident that the window and or door are going to be able to sustain different loads. There are 4 different classifications, 4 forced entry resistance with, you have a grade 10, 20, 30, and 40, and each one being a higher grade. Once you pass forced entry resistance, there are several different component type tests depending on the type of product. That if you have a double hung window, you do operating force, and you do a couple of different other torsion tests. And then if you have a crank out casement window, you do it. There's a side load test, and there's a couple other tests to make sure that if you happen to leave your window open and a heavy gust of wind would blow, it's not going to break the hinges and the operator and blow the window off. Once all the testing is completed, what the test lab will do is they will actually cut up the window and then compare the key components of the window to the manufacturer's drawings. Because basically, we want to make sure that the window that was tested is the window that they make every day. So there's typically, you have your sash components and your frame components and your structural members. You'll compare, a half a dozen of the key measurements on their drawings and then verify that they are within tolerance. And if they are within tolerance, the test lab will write up a test report detailing how the window was made, all of the test results, and then also include a copy of the approved drawings or the verified drawings. And then that will get submitted to the manufacturer, who in turn will submit that to a certification body. And then the certification body, basically, they're responsible for the follow-up quality control checks that are done, which are basically our in-plant inspections. There are several certification programs out there that will do follow-up inspections to confirm. They'll take the test report that the lab wrote, and then they'll confirm that during their inspections that the windows that are being made on the lines, manufacturing lines, are the same as the window that was tested.
It's very rigorous.
So go ahead. It definitely is, and the reason is you want to make sure that the consumer is getting a quality product, and the way to get a quality product is to make sure that you have third parties. The test lab is a third party that is checking up on the manufacturer, and then the certification agency is the third party that is making sure that the test lab is doing things correctly, and then also doing the follow-ups. So you want to make sure, not only for a consumer, the two key components that are vital for the consumer are typically the water resistance of the product, and then also the structural load of the product. Because everybody knows, once you get water in your building, then you got to kind of go to the next level and try to figure out what's going on. So if the more robust the products can be, the less likely that water will be, and then you'll have damage during a windstorm of the product.
So let me ask you a couple of questions about the water and the structural, which are the two main things. On the water side of things, I'm going to put my expert hat on for a second. And, I've been in hearings and whatnot where opposing experts who may or may not be window experts make statements like, oh, windows are supposed to leak. Is that true?
No. Windows are never designed to leak. Quite often, I get those same questions, and quite often it all depends on the definition of leakage, I guess, is probably the way of looking at it. I've been in several depositions where it's a horizontal sliding window or it's a horizontal sliding patio door. And during a storm, water is visible in the sill track, the sill of the window, but it does not overflow into the residence, but there's water visible. So some homeowners and experts say, well, that's water leakage. And it really is not. The sliding window product is kind of made to accumulate water, and the sill height or the cavity of the sill, depending on the rating that you want to have, the performance level you want, will have various levels that water can only be pushed up so high depending on the wind speed that's out there. And then once the storm is over, it just drains back out. So yes, water can be visible in those tracks during a rainstorm, but is that considered water leakage? No, it is not.
So what's the exception to that rule with regards to windstorms? So if you have a window that's rated, well, your example of the 35-pound window, what 35 PSF certification pressure for a window, is the water test pressure also 35 or is it different?
Very good question. Yep. For laboratory testing, if you're testing a residential or light commercial window, your test pressure is done at 15% of your design pressure. So for example, the test pressure on our PG35 window, your laboratory test pressure would be done at 5.25 PSF. And then once you get into the field, just due to different applications and installations and just different field components, the water test pressure that you would conduct in a field test per AMA 502, 503, or 511, any of those documents, would be done at 2/3 of that laboratory test pressure, or for this case, it would be done at 35.
So if you've got a window that's got a water test pressure of 5.25, what is that about in hour?
5.25 would be right around 40 miles per hour.
Yeah, so somewhere in give or take. So if you had a wind-driven rainstorm with 60-mile-an-hour winds, what could happen?
The window product could leak, and the reason I say that, I'm not saying that it would leak, but the potential would be there because the window wasn't designed in that case designed for that storm that was out there. Most window manufacturers have different series of windows that are meant for different areas of the country or different environmental conditions. So like in the case of you mentioned a 60-mile-per-hour wind, if this was rated for, if it was a PG-35 window, that storm would be above what the window was rated at. So there is a potential that it would leak, yes, just because it's above the, I'm not saying that it would, but there's a potential that it would.
Yes, if you're in an area like a coastal area where you could get 60-mile-an-hour wind-driven rain, obviously it would be appropriate to have a higher rated product in that environment, and likely the code would require a higher rated product. Is that not true?
Yeah, that is correct. Yeah, kind of the industry guideline is ASC 7, which doesn't really give the water performance rating, but it'll give the minimum structural rating of the products and walls and roofs and the whole building that would be needed for that geographical area. And then based on that, and then you can backtrack and figure out what the actual water rating would be.
Yeah. So in the structural rating with the safety factor, so you have 35, a window that's rated at 35, and it's tested to 52.5 at the 1.5 safety factor. Why isn't it rated at 52.5 since it passed the test?
It's rated at the 35 because that's the performance level of the product that the unit should be able to sustain a 35 PSF storms or should be able to sustain many of the 35 PSF storms. So because it's rated at that, so if anything that 35 PSF or below storms that occur, the window should continue to perform at the level for many of those storms. The 52.5, the 1.5 times that, it's meant, as we mentioned, it's meant as a safety factor. So if it gets a numerous 52.5 PSF wind loads on it, then it's not meant to perform after that wind speed. It's meant to stay in the opening and keep the homeowners and everybody safe.
So you had mentioned, was it NAS standard?
NAFS, National American Fenestration Standard.
NAFS, which used to be ANSI AMA 101.
Yep, it's a North American Fenestration Standard. It used to be AMA 101. It still is AMA 101. It's just that NAFS is kind of the shortcut for it. Instead of saying it all out, yes. Yeah,
so NAFS is where it lays out all this criteria for certification of products. Is that correct?
Correct. NAFS lays all of the test methods and test procedures that are required to satisfy a product. And then the certification programs, each one will have their own individual criteria that they have above NAFS. But yeah, NAFS is the industry standard that envelopes the test procedures that are done.
And who are the organizations that are involved with publishing or keeping up with that document?
There are three organizations. One is FGIA, which I mentioned. It's the Fenestration and Glazing Industry Alliance. You have WDMA, which is the Window and Door Manufacturers Association. And then you have CSA, which is a Canadian Standards Association. Prior to, you're going to catch me on the exact year, I can't think of the exact year off the top of my head, but there were two, in North America, there were two different testing standards out there. Canada had their own standard, and then the United States had their standard AMA. And then they saw the two countries saw so much alliance. That's when they developed NAFS, and just all three organizations are working together now.
And then you also talked about once you complete all the testing, then you go to a certification organization, or I guess that's what I'd call it.
Mm-hmm.
And what are some examples of who that might be? Obviously, AMA's one.
Yeah, AMA is one. WDMA, which their certification program is called Hallmark, is another one. Keystone Certification is another. You have NAMI, North American Manufacturers Association, and then there are a few other ones also. Like for example, Miami-Dade County has their own program, but their program doesn't test, to the NAFS. But those are probably the key ones.
They all use some of the basic standards, and then maybe put their own wrinkle on it.
They all have to test. Have the product. For all of them, the product has to be tested to the NAFS standard and pass the NAFS standard for all of those programs. But what they'll do is the differences are, the frequency of retesting to verify that the windows are still being made. It can be once every 10 years that a window gets pulled off the line and sent to a lab, or once every 4 years. Each one has their own wrinkle there. And then the other wrinkle is basically the frequency of inspections that are being done.
So let's shift gears. You mentioned thermal, and I know thermal is becoming more and more, there's a bigger and bigger emphasis on thermal from the way things used to be. So tell us a little bit about the thermal requirements and the testing that's done. I know there's calculations also, because nowadays window manufacturers not only need the performance criteria, but they also need the thermal information as well. Is that right?
Correct. Yeah, the thermal is primarily being regulated through NFRC, which is a National Fenestration Rating Council. The way window manufacturers will get their product thermally certified is it's initially done through computer simulations. So what window manufacturer will do is they will send all of their window drawings along with profile drawings, the assembly and profile drawings. They'll send their drawings in electronic format to a NFRC accredited lab, simulation lab, and then they'll also have all of their different types of glass options that they want to offer. I still remember one which just amazed me probably about 10 years back. There was a manufacturer that had 3,112, that number 6 in my head, 3,112 different glass options that they offer in their window products. When I say glass options, that
wow.
means different types. Yeah, it was wild. When we did our report, it was book. So that's why computer simulation came out in probably about 20 years back. Prior to then, you had to physically test every product in order to get the U value ratings. Now it can be done by computer simulation, which really streamlines it. So once all the different glass options are put in, then the computer kind of just crunches the numbers out. It'll give a U factor, a solar heat gain coefficient, and a visible light transmittance factor for each of those different glass options. So you'll have this large matrix of glass options with those ratings. And then what gets done is the manufacturer will, along with the simulation lab, will typically pick one of the best U value rated product glass option, and then that option will get manufactured and sent into the test lab, who will install it into a thermal chamber, which is a different name for it, is a guarded hot box. And it will be tested for NFRC 102. And that test procedure is basically you'll have a perpendicular wind on the exterior. Let me backtrack a little bit. The product, the chamber it's 2 rooms separated by a wall. On the one side, you have the room is kept at a cold temperature, typically right around 0 degrees, along with a perpendicular wind being blown on the product that is installed in that wall. On the opposite side, you'll measure the amount of energy that it keeps, to keep that room at 70 degrees, and then that amount of energy gets converted into your watts, and then it gets converted into BTU per hour per square foot per degree Fahrenheit temperature difference between the interior and exterior, and then which is your U value. And then that U value is compared to the simulated U value, which will, as long as they're within tolerance of each other. If they're within tolerance of each other, that means that the window manufacturer can actually make a window with the way their drawings show and the way they were simulated. So if they match, then the window is tore apart once again compared to the drawings, just like their water structural program. And then the test report that product line is validated. So then what the manufacturer will do is they'll send that simulation matrix report to a certification agency, who will in turn upload all of that data, to the certified product directory, the NFRC certified, and then consumers can go into that directory, and depending on the location and the requirements that they have for their residents, can pick and choose the window and glazing option that is needed for that location. To help the consumer to to give it an even playing field, since all manufacturers have to simulate and test to the same standards. Everybody, they're all rated the same through the same procedures. Then they can pick and choose the one that's best for their location.
So you mentioned consumer. So if I'm a consumer, all these terms, I don't know what they mean or what they're for. So let's go through that. What is a U value?
The U value is basically the amount of energy that conducts through a product. That's pretty simple terms, but it's basically the amount of energy that transmits through a product. So the lower the U value rating, the better the product is at not allowing heat to transfer through.
So the U value is basically, is that kind of like insulation as far as, the better it is, the more resistant it is to heat or cold going in or out?
Correct. Yeah. Basically, the U value is the reciprocal of the R value. So if you have an R value of insulating product, of insulation, like you have an R30 wall, your U value would be 1 divided by 30. So that's what your U value would be. So they're basically the same thing. It's just reciprocal of each other.
And then you mentioned solar heat gain. What's that?
Correct. Solar heat gain is the amount of heat that transfers mostly just through the glass. So it's the amount of heat gain that the product will allow from the sun, basically through solar radiation. If you put some low emissivity type coatings or tints on a product, it will deflect the solar radiation back out of the building. So your solar heat gain will be less, which is what you need for the southern half of the United States. For the northern half of the United States, quite often you want to have, in the cold months, you like to have that solar heat gain. So there's different types of coatings that will allow the solar radiation to come through in order to assist in heating up your homes. So depending on the area of the country, in the southern portion of the United States, you want to have a good solar heat gain coefficient, and then in the northern, you want to have it so it allows some through.
So the Minnesota glass is not the same as the Florida glass?
No, it is not. The Minnesota glass will typically have, it's a low emissivity coating. It's typically they're selective, so they just allow certain rays, and it'll allow the solar radiation to come through. And then when it tries to go back out of the window, depending on the surface that's on, it'll bounce it back to keep that energy to stay inside your home. In the south, you don't want to have that solar heat coming into your into your home, so it'll block it right away and keep it from coming in.
I put new windows in my house in Florida maybe 5 or 6, maybe even longer than that, 6 or 7 years ago. And, they weren't that old. They had tinted glass at the time. And the new windows had the low E coating on it. And it was a very noticeable difference when the sun hit it. Like with the tinted glass, the sun would hit it and the room would get hotter and hotter and hotter. And the low E glass, really did a nice job. You could still feel heat coming through, but not nearly as much as before that.
The technology has come a long ways. I remember back when the house that I'm in right now was built in the 60s, and when we moved in the 90s, it had this clear glass. Because in the 60s there really wasn't such a thing as any type of low E. And right away I put new windows after the first winter, I should say. We put all the windows in, and you can definitely tell the difference. Yeah.
And then the third thing that you mentioned was visible light transmission.
Correct. Yes, that's basically when you had mentioned about your windows from 5 or 6 years ago. They probably had a fairly heavy tint on, which deflects the visible portion of the sunlight out. But you still have your infrared and that type of thing, which is what low E's work on, is more in the infrared portion. So the visible light transmittance, depending on the type of building that you have and where you're at, that's typically done via the tints that are put on the glass, and that'll just collect out the visible portion of the sun rays. That assists with. It does assist with some solar heat gain, but it'll assist with user comfort So it's not always bright in your house. Also just with sun fade of the different furnishings inside your home. One of the trade-offs that you need to look at is it's been shown that for a person's health, you want to have as much sunlight as possible. So you don't want to make it too dark, so you don't allow any sunlight in, because then if you make it too dark, then you have to turn the light bulbs on the inside of your home, so you're using energy then. So it's kind of a catch-22. But visible light transmittance is basically the blocking of the visible light of.
I know, from thinking back to the projects that I've worked on as a design consultant or construction consultant, solar heat gain and visible light transmittance are a big deal with architects. They want to, keep the heat out or in wherever the project is, but at the same time, they want to have as much natural light as possible. And not too much so it's bright. There's always, you hear these horror stories about, people move into a building and it's reflecting off the one next door, whatever, and they all have to wear sunglasses sitting at their desks. But to get that balance right is a really big deal, I know, with architects these days, as far as energy and then as you said, the user comfort.
Yeah, correct. Yeah. Commercial structures, that's probably one of the larger things. Yeah, you're correct.
One other thing that you mentioned when you were talking about thermal testing in the beginning was condensation resistance. Is that a rating, or how does that fit in with this whole everything that we've been talking about?
Yeah, the condensation resistance, there's a couple of different ways that it's being determined. There's actually more than a couple, but the main ways are NFRC is doing it via simulations. It's in NFRC 501. And then there's also the AMA 1503, which is a physical test. But yeah, it's a rating. It's a comparison rating. Like for the AMA 1503, it goes in numerical five increments. And the higher the number, the better resistant to condensation that the product has. And the test is done, basically, while the U-value test is done, the condensation resistance factor test can be done also. And the way it's determined is you put different thermocouples, you attach them to the interior of your window or door on the glass, and then also at key locations on the framing of the door. So you measure the temperature of the interior surfaces of the product, and then through calculations, then your CRF, your condensation resistance factor, is calculated. And like I mentioned, the higher the number, the more resistant to condensation that product is. It's not saying that condensation won't occur. It's just saying that as a rating system between product A to product B, if product A has a CRF number of 40 and product B has a CRF number of 45, the product B will be more resistant to a potential condensation developing.
So I think about all this, and I think the average consumer, I know the average consumer, and I think maybe even a lot of professionals don't really grasp how much technology is involved with windows and doors and all the things that are evaluated and all the things that need to be considered. And, it's more than just looking out through a piece of glass and open and close it and walk through it. There's a lot of other factors, and this has been really interesting. I have a lot more that I want to go over with you, and I think that this is just screaming for a part 2 to this podcast. Would you, what do you think about that? Come back, because I want to go through all the field work and the expert work and things like that. So I was thinking maybe we do that in another podcast. Is that okay to you?
Yeah, I think that makes total sense. Yeah, it's always good to have kind of the background information, which, and I believe the background information is more of the laboratory and design and that type of aspect. And then, podcast 2 could be, how is that actually taken into the field for different types of settings. That is correct.
And that's where it all can go haywire, correct?
Exactly, because I get asked all the time, what window should I put in my house? And I say, it all depends, on the look that you want. And then I also tell them you can have a lower performance grade window. If it's installed perfectly, will perform great. But you can have a high performance grade window in the lab, and if it's installed poorly, you're going to have problems. It all comes to fruition in the field.
Yep. Well, listen, Dan, you did a great job explaining some pretty complicated technical stuff and making it real and understandable. So I thank you for that. And I look forward to the next part 2 of this. And thanks so much for your time today. And as I say, we'll do it again.
Thank you for having me. And like I mentioned initially, it's been a pleasure being on board with GCI Consultants and looking forward to more and more and growing. Thank you.
We're all super excited about it. So I'd like to thank everyone for listening to our podcast today, and I invite you to take a further look at GCI Consultant Services on our website at www.gciconsultants.com. You can also reach out to any of our experts at 877-740-9990. I'll say it again, 877-740-9990. Any of your building envelope consulting needs. Thank you once again. I look forward to talking with you again, and Dan also on our next episode on our Everything Building Envelope podcast.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.